The North Carolina Renewable Ocean Energy Program was created in 2010. Senator Baz Knight was representing the coastal area, and he recognized the tremendous amount of energy that we have on the coast. His intuition was that there ought to be a way that we could harness some of that to service our energy needs for the state. And as a result of that, we created this program at that legislative session, and it has continued on through today with significant amount of state funding. Our Renewable Ocean Energy Program in North Carolina is focused on 4 major areas. The first area is development of magnetic gears to be able to increase our efficiencies of our power takeoff systems in the water in terms of waves and tidal turbines.
And the magnetic gearbox has no physical gears, no mechanical gears are connecting. It's all non-contact. So it has some advantages in that it won't have the wear and maintenance problems that a mechanical gearbox would have. And we're trying to show that it can have high torque density at the same time.
Secondly, we really are engaged in compressed air energy storage, which is a way in which we can essentially provide base load power for the industry that is delivering power to your home when you need it and as you need it. Thirdly, we're very much engaged in looking at the Gulf Stream. The Gulf Stream is a tremendous source of energy. Enough energy there that could easily power nearly half, if not 3/4, of the needs of the state of North Carolina. And then fourthly, we're extremely interested in seeing how the environment fits around this.
Behind me is a 150 kilohertz acoustic Doppler current profiler and the accompanying pod, and it will measure currents above it from about 250 meters water depth, so it'll sit on the bottom, and we'll measure the currents above it all the way almost to the surface. We're really interested in the resource that's potentially available from the Gulf Stream for ocean energy, so we've chosen what we believe is the most likely location for an ocean energy turbine. So we're going to put this instrument there, and we're going to study the currents for a long period of time, probably 6 months.
When we begin to explore energy from the ocean, we need to know what that environment is. Everywhere from the physics to the chemistry to the biology of the environment. Our renewable energy program is directly connected to the Outer Banks in a number of ways. This is the most energetic part of the Atlantic coastline south, say, of Massachusetts. We have larger waves than anything south of us. So this gives us a great deal of energy in the Outer Banks. The presence of that energy source there and the potential for the development of it means a great deal to the future of the Outer Banks. In order to accomplish our mission, we have a partnership with the 3 colleges of engineering in the state: NC State, NC and UNC Charlotte. In addition to that, we have also invited some other people from outside the state of North Carolina that are very engaged in these types of energy developments as well. And we're very pleased to be working with them. We're also involved in some numerical modeling that's going to better inform us in terms of the physics between structures and the ocean environment. For example, behind me you see a screen of a wave energy device and how it's functioning in a water environment in a numerical model that we've developed. We are continuing to contribute to this using smooth particle hydrodynamics so we can actually go from the wave energy into mechanical and electrical energy. I think renewable energy is a real opportunity for the state. We need to have that renewable energy portfolio. We've talked about renewable energy from using lots of other resources, the sun, the wind. But I think marine hydrokinetics also has a very strong place, and it has such a strong place because there is such strong energy in our backyard. And I can tell you right now, It may not be happening this year, it may not be in the field next year, but at some point in the future, we're going to be developing that energy in our backyard, and it's going to be powering our lights and homes.